In this problem, we're going to find the inverse of a 3 by 3 matrix. Now, you probably remember that when you're doing an inverse of a 2 by 2 matrix, there's a simple formula. There's no simple formula for this one. There is a formula, but it's a complete nightmare. And what I'm about to show you, as bad as it is, believe me, it's the better option. So what we're going to do is we're going to go through a procedure here. You start with an augmented matrix. Look at this thing. We're starting with this augmented matrix, and I've written it right here. We take the matrix A, and we stick an identity matrix next to it. Okay, now, you're then going to proceed through some row operations, and we don't know what that is yet. We'll find out. But when you know you're done when you've got this identity matrix on the left. Then what's on the right side is the inverse that you were looking for. Okay, so it sounds pretty simple. There's only 3 steps to it. We're going to follow a certain priority of row operations that I've drawn on the right here. First thing I always do is deal with the upper left. I want to make that a 1. Second thing I always do after that is the next row down. I go for a 0. Then, third thing, I go for another 0 below that. Fourth thing, I jump up here to the middle section, okay? And I'm shooting for that 1, then down here to the 5th, and so on until you have created the identity matrix on the right-hand side. I really want you to follow this order of operations. It's not required, but it's just the smart thing to do. It will save you time. You'll usually never end up backtracking or undoing steps if you do this. And one final note. Before you operate matrices, please make sure you have eaten and you are well rested and there are no sharp objects lying nearby. So with that, we're going to get started on this thing. And what I'm going to do, every time I'm looking at a matrix, and I'm going to do something to it, I will explain what's happening on the right side so we can try to get through this a little quicker. So the first thing you want to do, remember, is turn this -2 into a 1. Now you might be thinking, oh, I just divide by -2. And yes, that would work. But my only caution is you're going to create fractions. And the only thing more annoying than matrices and row operations is when you have fractions to deal with. So let's not do that. Is there another thing we could do? Well, how about this? What if we replace row 1, not with row 1 divided by -2, but with the following. With row 1 minus row 3. Take a look at what's going to happen. I'm going to do -2 minus -3. That's -2 plus 3. That's 1. I get the one I want with no fractions. So, here we go. I've written the changes in green. Now what? Well, the next thing I want to do is get the second entry to be 0. And with this 1 right here, I have a really easy way to do that. I'm going to replace row 2 with, remember you can't multiply row 2 by 0, that's not allowed. But we can replace row 2 with row 2 minus, not row 1, we're going to need to do a little better than that. Row 2 minus 2 times row 1. Okay, so I will be doing 2 minus 2 times 1. Okay, if you think about that for a second, you should realize you're going to get 0 there. And that's what we have here. So with every entry, just walk through these entries carefully. Watch. 2 minus 2 times 1, that gives me 0. 0 minus 0 gives me 0. 3 minus 2 times 1 gives me 1, and so on and so on and so on. Okay, you just walk through this very slowly and carefully. Now, we're forming up an identity matrix. This is already looking better on the left, but I still need to keep on following this procedure. Next in line is the third entry. I want that to be 0. Remember, you can't multiply by 0, but you can add other rows. So what I'm going to do here is say the following. I'm going to replace row 3 with row 3 plus 3 times row 1. Okay, and that's going to get me to the following. I took -3 plus 3 times 1, that got a 0. 1 plus 3 times 0, that just got me a 1 right here. -2 plus 3 times 1, that got me to +1. And I keep going all the way across, right? Here, 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 and so on until you have reached the very end of the augmented matrix. Okay, next, We're going to take this one, and what should we do? Let's see. Well, here's an interesting case. I see a shortcut that we might be able to save ourselves a few steps on. Remember what I want. I want this entry right here to be 1. Well, one thing we're allowed to do, you can multiply a row by a number, a non-zero number. You can replace a row with itself plus some other row, or you can swap a row. I don't often swap rows, but we've got a nice chance here. Swap rows, let's see, R2 and R3. Look what's going to happen. This 1 is just going to trade places up there. All the other numbers are going to trade places too, but it's that one that I care about, the 4th entry. So here we go. Look what happens. I switched those 2 rows, and right away we got real lucky here. Not only did I get a 1 right here where I wanted, but I got a 0 below it, kind of for free. And, this is so exciting, I got a 1 over here. That's like a 3 for 1. This hardly ever happens. Okay, so count your lucky stars. We're almost done with this thing now. The next thing I want, and remember, I've gone this way, and then I've gone up and down, and now I'm going over, and that's already a 1. Okay, so I followed this nice pattern, and now I'm going to start going up. So I want to turn this number right here into a 0. How are we going to do that? Well, let me clean this up a little bit. It's this 0 right here that I'm going for. How about we try this? Let's do, let's replace row 2 with row 2 minus row 3. Okay, so I'm going to be doing 1 minus 1. Not too bad. This is what we end up with. And you see now the identity matrix is almost completely formed. There's only one little thing. I check here, that's already a 0. I'm very happy. This is the last number left. I have to get that to be equal to 0. And the way I'm going to do it is I'm going to replace row 1 with row 1 minus row 3. Okay, follow through the math. Here's what we get. Finally, this wasn't even a bad one. We have the identity matrix over here, which means on the right, you have a to the negative 1. Okay, so that's it. A to the negative 1 equals 3, 5, negative 2, negative 1, negative 1, 1, negative 3, negative 4, and 2, and we are donezo.